All right. So, welcome everybody to the 9 April. I had to think about that. Laser SIG. Tonight we're going to have Steve Walters from American Photonics talk to us for a few minutes. But before we get to him, a couple of little other pieces of business. Lightburn, I don't know if everybody saw my post. Lightburn came out with version 9.23, which fixed all their hopefully bugs in 9.21 and 9.22. And they put out a really nice apology letter for not doing a good QA job. After Steve gets through talking, we are working on an affiliate program with them, so that if you go through our website, the codes are on there, or you can just click on the link and it automatically puts the code in there. Basically, the shop gets some money back off of your purchase, and you get a discount too. So we're going to try and support the guy that's supporting us here. So I think those were the last two. If you have any problems getting to that link, let me know, or call Travis and harass him. So does anybody else have anything before we get into the presentation? I mean, this is sort of I really want to get to Steve and talk. Steve's on the East Coast, by the way, so it's probably past his bedtime by now. So Stephen Walters is the president and CEO of American Photonics, and they're out of Sarasota, Florida. And I'm going to let him tell us a little bit more about what he does and how he does, and he's going to show us talk to us a little bit about lens focal length and other things. So Steve, I'm going to pin you on since I figure out which one. There it is. So now,
okay.
So now you're pinned on everybody's screen.
Okay. Hello, everybody. First correction: my wife is the CEO. Okay.
Uh-oh.
I'm only the chairman and president. Okay. So.
and Anna's on here, right? That's who that.
No, I don't. She might be, because she's in the other room. She might be actually just so she can critique me after this is all over.
There you go. She's going to
So I'm Steve Walters, owner of American Photonics. American Photonics was founded in 2001, and we were founded making. Pretty much, we started right off with hiring the right people, making zinc solenoid high power CO2 laser optics. And now I distinguish high power as more than 500 watts and up to 6,000 watts. That's high power. For me, low power would be, your 40 to 500 watt systems. For all the years, I say, and up until 2020, we pretty much only sold through distribution. We sold to OEMs. We do still sell to OEMs. Epilogue, Universal, and a few of the others, Sinrad. We do have a lot of business in the military, Lockheed, Ball Aerospace. We only do infrared optics, where our materials are zinc solenoid, gallium arsenide, germanium, zinc solenoid, and then it's just those. They're all soft crystals, and that's all our company does. So that's basically what we do now. And being that I normally travel a lot, in 2020, our sales did take a hit because of that, and we decided to go more to direct to end users. My wife created the store, and I had a few product lines, a few products I was working on for many years. And one of the alignment tool, and I'll go over my importance of the alignment tool in the third mirror, so you guys understand that better. But so 2020 was a big year for us for going direct to the end user, and it's really coming out really well. And I hope you guys can appreciate the parts that I'm making and selling to you. These are all, so back about 5 years ago, I bought a machine myself because I realized the slow power stuff was going to be important. And I had just a terrible time getting the alignment right. And I realized, and I do all kind of alignments. I have optical test benches to check my optics, so I'm very familiar with doing optical alignment stuff. But you know, the design of the machine really desperately needs some alignment tools. So some of the things I brought is this was some of my first alignment tools that I designed probably about 5 years ago, and they kind of worked, but they were just incredibly expensive and weren't practical. My first lens system, you know, for gluing was something like this. I realized this would go in the machine, and then the lens would go into there. And I realized to do a good alignment, you wanted to put something here to represent the lens, because that's important to, you know, the center, the laser hitting the center of the lens at 90 degrees is the most important thing. So the concept was to remove the lens and then put in, you know, an alignment tool, you know, and then align everything as if it were the lens, not the other way around. And then, but that just really didn't work out. And, you know, and because more or less because of the expense of it, I made something that was a little too complicated and a little too expensive to make, a little too expensive to sell. The Chinese machines, people didn't want to spend $300-400 for an alignment tool and lenses that were, when they could buy, you know, cheaper lenses for a lot less money. So I came up with this as here's the basics of my alignment tool. I guess other things had to happen. It's a laser bore sight bullet and a piece of aluminum where I get a really small hole in there, and I take this and I put this in a lathe, and I spin it and I shoot the laser out about 30 feet, and I turn this diameter right here so that it's square and straight to about 30 feet out on a dot on the wall. And then this is precision made. And again, it takes that laser from a big dot to about this is about a 0.5 millimeter hole in the center of this. So it gets it real accurate. And then I have 13 different sizes of these. So it's basically a laser bore sight for your laser machine as opposed to a gun. Okay. And then this would go in the machine into the tube, and it's there sitting there. So when you take your lens out, it goes in there, and it's basically a perfect representation of your lens, dead center, and a perfect 90 degrees to where your lens would be. You know, one of the things, you know, we make a lens, and to get a good quality cut, to get the best quality cut, you know, we find that you can get the curves or the flats like this, and if you wedge them a little bit, you'll really affects the focal point and how tight the focal point is. And it's the same basic thing as if you didn't hit if you hit the lens at a 1/2 degree or a 1/3 of a degree. You really, you know, with the experiments with Epilogue we did, we found that even 10 minutes seriously affected how good a quality they could get with engraving. So, and that's easy to be off. Now, many of you probably have seen my videos. It goes through the alignment and how that is important. Now, you're all laser certified, so if you've done alignment on the machine, you realize if you're doing the alignment right conventionally, you're aligning on the z-axis. So you have a point. You have your head like this, and you shoot the laser through it. And you put a piece of tape on the bed, and you then move the bed down like 4 inches, and you make sure you adjust the mirror here until the point hits the same spot, maybe 4 inches apart. Now the problem with that is the laser head could be, you know, cocked a little bit. You know, we're talking, what we found that important was, you know, a 1/2 degree is important. Now you can put a square on this, but it still could easily be more than a 1/2 degree or a 1/2 degree off. And now when you're lining your laser up to your z-axis of travel, you're not lining it up to the lens. You could easily be off. Okay, which is that's the purpose of the alignment tool. Alignment is going to be the biggest factor as far as getting the best quality in engraving. But a big part of it also we found out is, you know, you can get, when cutting your wood, you're going to get either a nice clean cut and with very little charring on the top or bottom, or you're going to get some charring, and you're still going to cut really well. Your post work from the laser after cutting it could be greatly reduced the better your alignment is and the better your lens is. Okay, and that's going to save you time and money in the end. Of that, I have, so I don't, again, you don't have, do you have a head like this in your machine, or like this, or bigger? These are Cloud Ray K heads. I have what would be a K40 type head that I make adapters for. Let me move into the next part of so alignment is a big part of it. I do, I make my low power lenses with the same quality and same material that I make my 6,000 watt lenses also. So a lot of the Chinese manufacturers lenses, they'll advertise made in the USA zinc solenoid, and that could be technically true, but that is not going to be laser grade material. Now, what difference does that make? I think in the end, every little thing, you talk about how good the quality, how good your wedge is on your end, how good your spheres are when you manufacture, how good the quality of your material is, how good the surface finishes are. All of these things compound and add up to making I think in the end, you're going to get a better product if you buy a higher quality lens. Alignment, again, and nothing works that great if your alignment isn't good. So, that's something you really need to focus on. What I've created as the product also, which some people have seen, is this. It is basically the lens, but like Epilog, Trotec, Universal, I've glued it in the holder. Again, this is a very, very soft crystal. I put it on par with, say, onyx, really soft. You can take a little tool and work it by hand and make shapes. It's really soft. The crystal is a certain size, and you can actually squeeze the crystal and distort the crystal, and it affects your beam quality. I actually have one of the videos up there where I can take the lens like this, and I can just squeeze it in my fingers, and through cross polarizer, you can watch the crystal inside of it changing its shape, and that will affect how much energy gets through it, how much reflection comes off of it, and the beam quality. So if your machine doesn't have an O-ring in it, and a lot of machines don't come with O-rings, the K40 doesn't come with an O-ring. A lot of the OM Tech machines, they don't come with O-rings. If it doesn't come with an O-ring, you should get an O-ring immediately and put it in there. Worst, at bare minimum. Again, this is a method of assembling and putting a lens in place that it copies Epilog, Universal, Trotec, and most of the really high dollar machines. And the purpose of that is a couple reasons. One, the glue. I set the lens in there, and the glue works. It takes 24 hours to cure, and it holds that lens in there, completely suspends it, so there's no pressures on it whatsoever. That's one thing it does. Two, it's actually easier to clean. For those of you who have your machines, you should clean your lens often. The more you clean it, the better it's going to. The longer it's going to last, the better it's going to work. And I don't know almost anybody who hasn't taken this lens out and chipped it, taking it out, putting it in, or dropped it, chipped the edge of it, and now you have a bad lens, or you should have a spare. So this eliminates that. I can drop this on the ground. I'm not going to ever damage that lens. So it holds it really good and makes it easier to clean.
So Steve,
yes.
Can I stop you for a second? What do you suggest we clean our lenses with?
Okay, I have a lens cleaning kit I sell. First of all, I suggest for materials, use pure acetone or pure alcohol. Isopropyl, 99%, acetone, 99%. Fingernail polish is not good. It's going to have a dye in it. 70% alcohol at the store, not good. It has water in it. The coating on here has a couple exotic materials that have to work, and it's like thorium fluoride. The Chinese lenses are made with yttrium fluoride. That material in the coating, it absorbs water like crazy. Okay, so now that water is intrinsic water. It's not part of the coating. It is absorbed by it. But when you fire your laser, the first thing that's going to happen is that water is going to bake right out of it. And it's not going to destroy your coating immediately, but it will definitely shorten the life. Okay. Acetone alcohol, this is a stone. It's going to handle it, doesn't damage it at all. Okay. The little kit that I sell for $12 or $13. It is a small jar of acetone with a dropper. Okay. And then I sell, comes with 100 of these. These are 6-inch long Q-tips, so you can get to your mirrors. Okay, so you can actually, get down, put a couple drops and clean the back of the lens. Anything gets in the back of the lens will basically be dust. It's not going to be dirt, nothing really soiled in there. So a couple drops of acetone down there, or alcohol if you're using alcohol, and then just swish it around and just sop it up, and the back of the lens will be clean. Okay. The other thing I supply is the cleaning cloths I use inside my factory. This is a lint-free cotton wipe. So, for my kit, I have this acetone, 100 Q-tips, and 10 of those cotton wipes for $12, $13. I suggest, again, people have used the denatured alcohol. I don't know. I think it probably works good. I don't have any complaints about that. As long as it doesn't have water in it, it's probably good. Okay. The Zeiss wipes, I see that written a lot, and I think there's water in those, but I know people use them. I mean, it's not going to destroy your lens right away, but I think it's really going to shorten the life of it. Okay. I would recommend, I'd like to actually change the trend and say, you should clean your lens every day. You should clean your lens every day at the end of the day, after you're done working, because of a couple reasons. If you're pushing some water through, say your coalescing filter isn't working 100%, and if at the end of the day after cutting you pull this thing out, you'll see it. If you wait till the morning or the next day or the next week, it'll be gone. It'll be evaporated. It'll be in the coating. It'll damage. It'll bake its way out. But at the end of the day is the only time you're really going to see if your compressor is pushing any water out. Your air dryer could be failing. Your coalescing filter your desk could be getting full, and you could at some point. And if you check it every day, you'll know, and the water as it comes through, it'll get on there. It'll actually heat up the coating too as it's coming into the air, and it'll shorten the life of your lens. So, or your compressor at some point might start pushing oil through, might start passing the oil, and this system here literally takes. I'm telling you, you can take the lens out in 30 seconds, clean it, and put it back. Normal systems are kind of like this. There's a little where it has the lenses in here, and you have this is actually easy. Okay, this comes out, and the lens sits inside here, and it's being squeezed. But other ones have a little ring in there that then you have a washer, and then you're dumping this out on a tissue, or then you're touching with your fingers, which are loaded with oil. You don't want oil on there. It's just not. We all wear gloves when we're touching these optics, because the oils don't. If the oil sits on your lens for more than an hour, it like never comes off. If I put my fingerprint on a lens and I let it sit there for an hour, the girls can't get it off. It's on there permanently. So when we handle the optics in our factory, we only use gloves, and they're lotion and powder free gloves. They're special gloves. But something like this, you never touch the lens. You don't have to touch it at all. Your fingers never get close to it. So it's real easy to, take the cloth, put a couple drops on there, wipe it nice, check it, or, use the Q-tip and just kind of lightly, because this can scratch it too. So you want to real light, if you do it, you want to do it real light like that, so you're not going to scratch it. Okay. So as far as cleaning, that's my suggestion. I know everybody's going to do it different. Some people say they clean it once a month or once a week. But if you have a system that's where the lenses are easy to clean, you're going to cut better. you don't know when you're going to smoke on that lens, or it's going to get a little dirty, or a little water, or a little oil. You just check it. If it's easy, check it every day and just clean it. That's what I suggest. Okay. And I make 13 different sizes of these, one for almost every Chinese style machine there is. Okay. They all come with their own nozzle. Again, one guy showed, here's a little kit I sell almost for all of them. And again, I believe in 4 sizes. I have an 1.5 inch for engraving. The 2 inch is what most machines come with. So in some of my kits, I leave the 2 inch out because you can always use a 2 inch you have. A 2.5 is a really good, I think, general purpose lens, and a 4 inch, which is going to be really for cutting. I mean, you got 2 inch thick styrofoam you want to cut. This is what you might want to use. Okay. All of these, this is what kit looks like. So what you're seeing here is I have an alignment tool. People say, this is a battery. Okay, it's a AAA battery. This is kind of weird, but one of the designs I have, all of these lenses are designed for the focal length of 4 inches longer, but from the tip of the nozzle to the perfect focal point is 10.5 millimeters, which is the same diameter as this battery. I picked that, I could have made it anything. 10.5 millimeters is as good as 7 or 8, 9. And everybody has one of these laying around. And one of the biggest things, I don't know how long, it probably only took me a day before I lost my focal gauge for mine. Okay, so I put that, and everybody has one of those. They can find that somewhere. And so go back to finding the right focus. All of these 10.5 millimeters is the perfect focal point. A lot of you have motorized beds. Every motorized bed I've ever seen, you push the up down button and it has one speed. It's full speed or it's stopped. And I couldn't seem to get my bed to stop where I wanted it to. I'd have a little gauge. And so I find it to be, in the end, to be best to loosen the screw and then adjust. Let me show you. Here's my lens on the cloud ray head, a small lens of mine. So you move your bed up close and then make the final adjustment by moving the lens up and down. Okay. Put the battery down on your work that you want to engrave on or cut, and make the final adjustment by sliding this head up and down. Get the bed close with the motor, make the final adjustments with your spacer. Okay. And those are most of the things I have to say about my tools and my stuff. Cleaning. I have adapters for the K40 that modifies it to use this system also. So this is a K40 style head. Okay. And then you take the part that holds the lens on and take that off and screw this into the K40 head. And then this gives you adjustable focus on your K40. So on your K40, you can do material up to, say, 3/8 of an inch or paper, and you can adjust the focus up and down instead of trying to move the work into the correct spot. Okay. A couple of you have my kits. Does anyone have any questions?
I'm going to unpin you there, so if anybody has a question, it will pop to whoever has a question.
No questions, but a suggestion.
Please.
Oh, wait, Randy, hang on a second.
Okay, Randy, I already know what you're going to say. Okay, let me tell you what. I just changed every one of my parts. Every one of my nozzles now is going to have a push to connect fitting. Okay, that honestly, I just received those. I received 5,000 push to connect fittings last week, and I'm currently in the process of taking new pictures and putting on the website. They're all going to have the push to connect fittings, and all the kits are going to have the 1/4 inch, the push to connect flow control also.
Okay.
Did I anticipate your question
That's
and
even
answer
better
it?
than what I was going to say. I was just going to say, include an extra piece of hose, because you gave me a push to connect.
I gave you one of these, right?
Yes, but then when I put it on the 2.5, which is what I'm using, the hose is on there. One I had to cut, and I couldn't get it off to put it on another, so I had to go to the store and get another one. But what you just did solves the problem.
Yeah, so I mean, I realized that is listen, it was a tough thing. I'm launching a new product, and you know, I'm competing with a mentality of the Chinese laser lenses that listen, I'm not the same price as them. You know, there's no, but I do believe that the extra $20 or $25 you might spend on my lens or my lens system, I hope you're getting enough advantages that you're actually going to see that cost benefit in what you produce. You know, that's what I'm hoping.
Yeah, I really liked your video that started off with leveling the bed, because my bed was not level and I didn't realize it. Now I had used a T and did the head 90 degrees to the bed, but if your gantry is level and the bed isn't, as it goes across, that's going to affect it even more. Alan and I both went through my laser, and I had done all of your steps in that it's a long video, I think like 29 or 39 minutes.
Oh no, I hate making videos that long, but you're right, it is a long one.
Hey, I highly recommend everybody on here watch that video, because you're going to find something on there that's going to help you. That right there is 1/4 inch, and the only one that didn't push through was this one, which is 10 speed, 10 and 25 power. Everything else blew through, no problem. I have not been able to cut 1/4 inch like that before, and that was one pass. I've cut 1/4 inch before. I got your stuff and watched your video, and it was 2 or 3 passes. So I'm fully behind you.
Well, thank you. You
Good
know,
stuff.
I actually had a video on there. I cut 3/4 inch Luan plywood with a 100 watt laser, and I swear I could have made it in one pass. We did it in 2. I didn't. There was no charring top or bottom, and I didn't even make any smoke. There was no smoke coming off of it, and it does come from, you know, having the laser hitting the center of the lens at 90 degrees, and then a good quality optic and good airflow. You know, because you know, if your head's off by a 1/2 degree, or seriously, if your head's off by a degree, you're not going to see it in your cuts. But if your laser hits the lens off by 1 degree, it's going to make a big difference in the the spherical aberration of the laser itself. It's going to change the shape of the laser. You're going to have a hot spot and a lighter spot on one side. It's really going to affect it. And listen, it may still cut really good, but the fact that it's hotter on one side and not as hot on this side is going to mean you're going to have some charring, maybe on the top, maybe you're going to make some fire as opposed to just incinerating the wood. And that's where that 1 degree might not seem important, and it's still going to work. You're still going to cut. You're still going to engrave, but it's just not going to give you other issues that you won't even realize it until you fix it. Okay.
Can you briefly discuss mirrors? Like what type of mirror for a CO2 laser? I see the SI and the MOs. I'm not quite sure type of mirror to get.
Well, everybody has their preference. I make only one mirror. I don't make Moly mirrors. The MO mirrors, I don't make them. Moly mirrors, by nature, okay, they reflect only 99% of the laser. Okay. If you have a beam combiner on your laser, the moly doesn't reflect that red very well either. So you're going to lose a lot of that power. The moly is when it's brand new and freshly polished, it's going to reflect 99%. A silicon mirror, my silicon mirrors, when they're coated, reflect 99.7%. Now, that's a total of 2%. You're going to have 2% loss through 3 moly mirrors or using 3 silicon mirrors. That's not a lot. That is a moly mirror that's brand new. Moly will oxidize and it will deteriorate over time. And okay, so it's not 99, now it'll be 98, now it's 97. It will not get better. A coated silicon mirror will not oxidize and will not change at all. It'll be 99.7 until the coating comes off. If you keep it clean and you take care of it and don't let it get smoky or you know, it'll last years. It really will last a long time. A moly mirror has no coating on it at all, so there's no coating to come off. People say they like it because it's more durable. Well, what they're really saying, I think, in my opinion, is they don't like cleaning their optics, and you can get it all sooty and run your 100-watt into it, and it's not going to make the coating won't come off because there is no coating. It's still, you can clean it off a week later, and you know. So I'm not going to. I don't think moly's the best. I think a silicon mirror is the best. I think
Okay,
that cleaning practices are. Everybody should keep their optics clean. You know, you have a 100-watt laser. You want 100 watts. You don't want it to be, you know, 100 watts today and, you know, 95 tomorrow. And so keep your stuff clean. It'll last longer.
Very good. Thank you.
Okay. And a lot of the original machines, the K40s, they come with glass mirrors also, and those are about as much garbage as those are really bad. I can't say enough bad things about those, but initially they do work. So. Do your machines have a beam combiner in them?
The green Paul takes care of our machines at the shop. So I think the reason he's asking these questions is we're about ready to rebuild them again and go into machine 3.0 instead of 2.0.
Well, when you say combiner, what do you mean by a combiner? I'll ask the stupid question. I don't understand what the combiner does. With the targeting LED
beam,
and the laser.
Yeah, so that's the part where you put the little red dot laser at the back. So I know the big green one has one.
Yes, we both our lasers, both the 100 watts have a targeting laser. So yes, they do have a beam combiner.
Okay, you know, and I'll tell you what I make for, you know, one of the, again, talking about the zinc selenide being very soft. Okay, now those beam combiners are typically, they go into a mount, right? I think this kind of probably looks something like this. Okay, so that sits at, you know, at 45 degrees, and the CO2 laser goes in and comes out. And there's probably a red laser that comes in and then bounces off of it and then joins, and it combines the CO2 laser and a red laser that goes through that way. Now, those are typically, I've seen all the ones I've seen from the Chinese, there's a little plastic screw that goes in an aluminum thing that pushes on the crystal right here or both places. And one of the stories I have is the guy was buying my beam combiners and he said my beam combiners weren't any good. He said he burnt a hole in his clothes because it was kind of sitting like this, and he was standing at the back of the machine aligning mirror 1, and it reflected, the CO2 reflected and hit his pants, and he gave it to me, and I checked it, and it was less than 1% reflection, which is what it's spec'd at. And it was a 100-watt laser, and to burn your clothes, I mean, you need like probably 5 watts to burn a hole in your clothes. And basically what he was doing, he was tightening down on the crystal, and it was causing the crystal to stress and causing a high reflection off of it. Okay. And again, that 5% is now lost. It's not going through, and it ended up, bouncing off and burning something. So what I've done, and this is about the same price as my regular beam combiner, is again like Epilogue and like Universal. I've glued it into a holder that fits right into the spot that goes where your beam combiner goes. If anything happens to your beam combiner, look at these as opposed to buying the one that is being pushed on by a screw. This will work really good. I
Okay,
have
no.
3 different styles.
Yeah, I stand corrected. Only one of the lasers has a beam combiner. The other one has the targeting laser on the, call it the gantry mirror head.
Yeah, little red laser that points down at an angle down at the
Yes,
spot.
yeah,
Yeah, that's a very common. I think those are actually a really good solution for most of these machines. I mean,
Yeah.
it's just for positioning your work.
Yeah.
Again, on the beam combiner, I also made this one. This fits in with where the 25 millimeter beam combiners go. And it's just that way you're pushing on the aluminum, and it's actually a little bit, it's a bit less money. It's like $20 less. And for as long as you're 100 watts or less, the beam size isn't too big. This would work really good also. And then you don't have to buy a new mount. It goes right in there. As far as, I guess you understand the fact that we'll talk, 1.5" focal length lenses will give you a smaller spot size, and for engraving, photo quality stuff. And if you're not really doing much in the way of cutting, you're only cutting 3 millimeter material, the 1.5" lens, focal length lens is a really good solution for that. I think the 2.5" lens is my next favorite lens. It's really a good all-round lens. I think you should be easily get, say, 300 DPI engraving, and even cut 1/2" plywood pretty easy with that. At 100 watts, you should be able to cut it pretty easy with that. I wouldn't even surprise if you cut 5/8 in one pass with the 2.5" focal length lens. The 4" focal length lens is really what if you're going to, you're gonna start cutting 3/4 inch, or I cut a 2x4 with a 4" lens and 100 watts. If you are going to cut something that has a curve to it, so you're cutting you're going to engrave on a flask or something round, then you don't have a rotary to spin the part around. The 4" has a long gradual lens. The focal point comes down, it converges very, very slowly. So it has a long, almost a 9 or 10 millimeter area where you can actually get 50 DPI or better. So if you have something that's curved and it's less than a 1/2" from the top of the curve to the bottom of the curve, you can take a 4" lens and probably easily engrave 50 to 100 DPI with that 4" lens all the way across the curve. So along with cutting thicker material, because of the slow convergence of the laser, it's also good for engraving curved surfaces. Any other questions?
Not exactly optics. I posted a link to a 3D printed nozzle that gives you laminar flow out of it. And the idea is that it keeps the turbulence away so the smoke can't get any particles that will then condense and fall back down. And you get an extremely clean cut. I was wondering if you have any experience with that sort of thing.
Not so. I've seen that 3D plastic nozzle. I know the people, when they cut thicker stuff, they're running high PSI. I mean, when we were cutting that 3/4 inch plywood with 100 watts, we were running like 60 PSI. And again, it didn't even make it. There was no smoke to actually come back when it was aligned right and everything was right. For engraving, I mean, I think it's about keeping the smoke away from the lens. You're right, and that But for cutting, I think you're going to do really good with just a good alignment and a good lens. I don't know that the laminar flow pushing the material out as it incinerates it. I mean, there's a lot of technology when you get up to 4, 5, 6,000 watts that does make a difference. They're also running hundreds of psi to push as they melt metal, to push it out of the way. So I do see a lot of people have problems with the plastic. They fall off and they catch on fire. So I just be careful with that also. But I have seen that, and maybe it might work really well. I'm not really sure. I haven't tested it.
Thanks.
You're welcome.
Well, thank you, Steve, for coming and talking to us. And like I said in the beginning, we're running an affiliate program with APC, and the shop gets a once a month check, I guess, for our percentage of everything that we buy, and then we also get a 5% discount on that for all the things we buy off of the website. So everybody support Steve.
Okay.
If you ever want to, Steve, if you ever want to use a beta tester, you see us, or there's the guys. David's our guy that like pushes our lasers to the limit, and the rest of us just use them.
Well, we talked about that before, and I do have a couple products I'm working on. One of which, and you said beta test, and I have a power reducer. Okay, it's actually what it's called. It's a partial reflector. Okay, it's a round window, kind of like this beam combiner. Okay, but what it does is it takes the CO2 laser, and I can let only, when it hits it, only 10% will go through. Okay, or I have two that I make really common, a 90% and a 70%. So it only let 10% through, or let 30%. They said, why would I want to take my laser and only let 10% go through? The reason is you have a high power laser. You have a 100-watt laser, and that 100-watt laser probably won't ignite or it won't make a CO2 beam until about 8, 9, 10 watts. And 8, 9, 10 watts is going to destroy some stuff. There's certain things you will not be able to engrave. You cannot probably engrave balsa wood. You probably can't use it on leather. You definitely can't engrave fabric or anything like that with 10 watts. You're just going to burn it. It's too much. That's the K40. You might actually find it more useful for some engraving because it's a 40-watt laser, and I know I can get it to produce about 3 watts, 3.5 watts. So the idea would be to make a quick, easy spot for a piece like this to go in, so that when you program your 100-watt laser to put out 15 watts, you actually get 1.5 watts. And now you can engrave paper if you wanted to without burning through it. You can take up to 30 watts. Now you have 3 watts. You can do leather, perfect. Where otherwise your 100-watt laser is going to be good for cutting, doing mugs or cutting maybe really hard oak, or if you want to cut it really deep, you can get high power. You can engrave it really deep, but for light, delicate engraving, it's not. Your 100-watt laser is not going to be really good. And that's something maybe if you're willing to, you can make some fixtures to mount this thing in the right place. I have a couple. I'd like you to maybe you could test that for me. I can work out the details of that.
Yeah.
Where does the rest of that heat go?
It would have to go into a heat dump. I use I have pure graphite that's used as a heat dump. But you're dumping. You're not running 100 watts dumping it. Okay, you're running 10 to 15 watts and dumping that into a piece of graphite, maybe connected to a piece of aluminum as a heat sink.
Got it. Okay.
And engraving is typically intermittent also. Even most engraving, if it's even a 50% duty cycle, it's a lot.
Yeah, I was just thinking that'd be perfect for grayscale engraving. I've tried that on the 100-watt laser, and I had to use a range of like 12 to 35% as my full gamut, and doesn't give very good. I mean, the gamut's not very good from that. And you're right, the cutoff, going from no burning to where it starts to burn just a little bit, it's pretty sharp. So I think that would work great in that case, because then you could probably take it all the way to the full 100% and get a very good gamut out of it, assuming your heat dump can take that kind of power continuously. Because this is for,
again, that's where that would be nice if you'd beta note, understand that it's a beta test. Yeah. You know, I make these, they're used for they're the output window on a laser. You know, that's typically what these things are used for, and I thought they'd be great for these machines.
Yeah, because my use case would be grayscale engraving, like 8x10 size, and it's basically going to go for 2 hours at continuous operation. So if it could handle that, that'd be great.
You know, where I'm thinking about, if we, you know, from mirror 1 to mirror 2, typically there's a piece of, you know, a hole in the piece of metal. And if I can make something that you or somebody could mount on that sheet metal that holds that at an angle, it's something you need to be able to take it out, because you don't want it there all the time. You don't be able to put it in and then take it out when you want to do cutting and use 100 watts. But that's what I'm thinking about putting it. Some kind of fixture that would go off and on in that area.
It would almost be like a beam combiner, only opposite.
It would be. It would be just like a beam combiner, but it would push either 70% or 90% of the beam into a beam dump.
So you could actually just use a little stand like the beam combiner uses, and just put it right in front of that hole that you're talking about. I know mine has a hole in it here, so.
Well, like I said, my idea is to actually use like this, a square piece that, you know, then I might 3D print something that's going to slide into, you know, it might sit there, and then the beam dump would sit in this area here. And then you could just, you know, slide this in, and now it passes the laser through it, but dumps most of it off that way. And when you don't want it, you just slide it out, take it out.
That would be interesting. We'll have to talk to the boss and see what he says about using the shop lasers. But I mean, I'd do it here, but mine's not a 100-watt laser, so it wouldn't help. I mean, it would knock it down, but it's not going to. It wouldn't. Not like the bigger ones would. Well, that's cool. We'll stay. I mean, if you want to try that, we can stay in touch, and maybe we can get a Zoom call with Travis and Paul and a couple other people that are taking care of the lasers, and we'll see what we can come up with.
How large would the beam dump be? Does that have to be attached to that reducer?
It has to be a piece of graphite that's not going to reflect any of the laser that hits it. That's going to somehow, like with some kind of a thermally conductive grease, you know, put it into some kind of piece of aluminum, which is then going to shed the heat quickly, move the heat out to the outside edges and shed it quickly.
Yeah, I'm just thinking about something on the gantry, but when the gantry goes to the position that's close to the number 1 mirror, is there physical room to mount this thing, at least in one of the 100-watt lasers at the shop? Something to think about. Okay.
You know, I had a guy also, he actually, just to keep his laser clean, he bought I make a special mount, and I modified it to put a window in it, that he mounted in that over that hole, so that no smoke could get back to the laser itself. I've been in some shops, boy, those things are just covered in, they're cutting wood, you know, 18 hours a day.
You've been to our shop, haven't you?
and you know, the glass tube, you can't even see that it's glass anymore, because it's covered with so much you soot and smoke and dust,
Yeah.
whatever it is.
That's ours. Yeah.
Yeah. Well, before we went to, so we're at shop 2.0 right now. Before we went to shop 2.0, when we were at 1.0, literally the laser beam set next to the dust extraction system. So it got micro dust all over it. So we had a team of people that every Sunday came in and took that laser apart and cleaned it and put it back together again. And the
Yeah, that's where you got to get in there and clean that. The output window has to be cleaned also of that laser.
So it was,
Here.
well, this was the, I mean, it was the
Yeah.
whole, so we've moved it now. We have a cleaner room, which is, at least it's got a couple, it's got a buffer zone of a classroom in between the woodworking, sawing, sanding area. I don't know how often Paul goes in and cleans it, but they are a lot better now that we've moved them away.
Yeah. It's just very inaccessible back in those corners to get to the tube. You have to be a contortionist. Yeah.
Our lasers are sort of not up against the wall, but they're, to get 2 lasers in the room, actually there's 3 in a row with the K40 in the middle. There's no walking room around them.
Okay. Well, he did it. He said he really liked it. He just bought this little piece of aluminum with round with 2 threaded holes with a window on it. And what he did was he cut a piece of wood with that he could actually put screws into my piece of aluminum, and that piece of wood had 4 holes. He self-tapped it, put self-tappers right in to he covered the whole entire hole, so that no air could pass from the laser back to mirror 1 or the tube. And that was his way of keeping that mirror 1 in the tube, keeping it cleaner.
Yeah. I guess if it was that dirty, it's almost like time to move your laser. But
Maybe.
all right, sir. Well, thank you very much. Does anybody else have any other questions before we? I guess we can see if anybody has anything really cool to share from this week or from the last month.
Well, before sharing anything, we had discussed Lightburn 9.23.
Yes, sir.
We were considering updating the shop Lightburn. However, the forums on Lightburn say that there are issues with 923 and USB communications from a PC to the laser. So we're holding off on doing that update. They particularly mentioned Mac OS USB from a Mac to the laser, but we're both running PCs at the shop, but we're going to hold that off until we get a little better feel for because we got some sporadic operation going on, and it may be the USB communication link instead of Ethernet to the laser. So just by the by. Okay.
Well, you guys are keeping it up. I've converted all 3 of my computers to 923, and it was actually 922 was crashing on me when I would try and convert a PDF to an SVG. About half the time it would crash, and I tried the same files again. I haven't had one crash since I went to 923. So
are you USB or Ethernet to the controller?
We're USB. I'm USB to the controller.
A shorter cable?
No, I've got a freaking 25 foot.
Oh, okay.
USB 3 cable.
You're one of the exceptions. All right, thanks.
Well, guys, I'm gonna head off to my bed now. So thank you for having me. I appreciate it very much,
Stephen. Very informative.
Thank you.
Okay.
Thank you very much.
Thanks.
And listen, we're open. You would call in. Lou answers the phone. He's extremely helpful. Also, if you have any problems or questions, he's our little service desk, and he'll help do it, whatever he can to help you. Okay.
All right.
Thank you very much.
Bye-bye.
All right. Bye-bye.
Thanks.
Bye.
All right. Does anybody have anything they want to show? Besides the helicopter on Mars? Oh. I want to see that helicopter on Mars move.
Yeah, I didn't make that. It doesn't move until Sunday.
Oh, okay.
Flies on Sunday.
So,
Yeah, that helicopter's got some Qualcomm chips in it. My code's on Mars.
is it? Cool.
Yeah.
So I found,
Hopefully it works.
I heard today that so is a piece of the Wright brothers airplane wing. I thought that was pretty cool.
That's
Somebody,
pretty cool.
I don't know. I want to be the guy that thinks about the stupid little things to add on to things so that it's cool to report on after it happens.
Oh yeah, like the rover itself has a little silicon chip on it where they laser engraved like 1 million people's names.
Yeah,
So it can be like, your name is on Mars.
yeah, yeah. So there's got to be that job. That's got to be something that I can do now that next Wednesday I retire, so I can have a
Woohoo.
real job. So, all right. Nobody has anything they want to show us cool that they've done? All of mine's going to the holiday gift thing. Okay, wait. Randy's got something. Oh, Randy's
Yeah, you
got my
can't see it.
Spider-Man. Hang on a
Yeah,
second.
your Spider-Man. Lights on. Nah, you're not going to be able to see it.
Yeah,
Well, yeah, this is Alan's Spider-Man that I
no,
made.
that's like 4 layers or something, right?
Four layers.
Yeah. So,
Turned out pretty good.
Is that wood or acrylic?
It's Baltic birch, 1/8 inch each layer.
Nice.
So the back layer is not painted, which is the eyes. And then you just paint each layer a different color.
so that's my new toy. My new thing is layered things. So I've been creating gnomes and comic book characters and Star Wars things here lately. But I gave them all to Gary Anderson for the holiday. So I don't even have any to show. But mine aren't painted. Peggy paints. Gary Anderson's wife does all my painting for me. She's the paint taskmaster. She just says, cut more. So, all right. All right. Well, if nobody else has anything, we'll do this again next month. Next month, I have the sales, I think he's the head of sales for Light Object. And he's going to give us a tour of the Light Object facility on Zoom. So
Cool.
same bat time, same bat channel. We'll be back. I'll put something out probably around the end of the month. So everybody, another reminder, and we can get everybody back in.
All right, thanks, Alan.
Great.
All right.
Thanks,
So-
Alan.
All right. Bye-bye.
Bye.
That
See you guys.